Hi there, students. What we're doing today is putting these radicals into equations, and we have to figure out what values of x will work for these crazy things. Now, something that's very frustrating is that radical equations will sometimes give us the wrong answers along with correct ones. So they'll give us all the correct ones that exist, but sometimes they give us these bogus answers, and so we have to check everything because just because we solve it and get an answer doesn't mean that it actually works. So what we're looking at is something underneath the square root. You know, it's like I'll crunch all these numbers and then I'll take the square root and I will get a 5. So that means that 3x plus 4 had better equal 25. That way when I take the square root, I get the 5. So how we solve this and how we look at these problems is we say, well, if we square both sides, then the square root of something squared is just itself. And then we get a 25 over here on the right. We already knew that, but this was the formal way to go about finding that. So then what I'll do is subtract 4 from both sides. Chunk, chunk, you're gone. And then we'll have 3x is 21. Divide both sides by 3, and I'll get that x is 7. Now, like I said, this might or might not work. Let's check it. Is 3 times 3, oops, 3 times 3. It's 3 times 7, sorry, plus 4. Does that equal 5? Well, I don't know. Let's see. That's the square root of 21 plus 4. That's the square root of 25. Oh yeah, that equals 5. This is a good solution. It checks. Let's look at another one. All right, let's play. The square root of this thing. Hey, look at this. The square root of that equals a negative 3. Nuh-uh. This is going to be no solution. So sometimes you can look at it and go, oh, I know it's going to be no solution. But let's say you didn't see that. So let's square both sides and see what happens. I get 4x plus 7 equals 9. Subtract 7 from both sides. Divide both sides by 4. X is 1/2. Now, I hate this, but I have to check it. This is my answer. And I got an answer, so let's see if it actually works, though. What's 4 times 1/2 plus 7? Well, this would be 4 times 1/2. That's 2 plus 7. And then this equals the square root of 9, which is 3. Oh, this is 3, but it's not negative 3, is it? Because this thing is supposed to equal negative 3, but it doesn't. No solution for this bad boy, but we already knew that. And this one could be a big mess if you were to square both sides right now. So let's not do that. Let's avoid making the mess, and let's go ahead and get the square root all by himself. That way, when I square both sides, it will be nice. So I'm going to move this 3. So go get square root on one side by himself. All right. So let me tell you, that'll make things a lot easier if you'll just do that very beginning. Otherwise, it becomes messy, messy. All right, 7 minus 3, that's a 4. Now you can square both sides. And we will get 5x minus 1 equals 16. Okay, cool. Now what I'm going to do is I'm going to add 1 to both sides. Add 1, choom, choom. And I get that 5x equals 17, and x is 17 over 5. Not sure if this will work or not, so let's just check and see. There's my answer. If it works, I'll keep it. If not, then I'll exit and then write no solution. So I have to check it. 5 times 17 over 5 minus 1 plus 3. We need to see what that equals. 5's cancel, leaving me with 17 minus 1 plus 3. This is square root of 16 plus 3. Square root of 16 is 4 plus 3. This thing equals a 7. It checks. Good deal. This one's nice. All right, if you'll remember, I said I want to get that square root all by himself. Well, he is there, so that makes me happy. I'm going to square both sides. Hold on. Blue. Square both sides. Remember, I'm squaring the entire side. This is where it gets really picky, so be very careful. T plus 5 times t plus 5 is actually t squared plus 10t plus 25. This is where most students make a little mistake, because remember that it's t plus 5 times t plus 5, so you'll have to, what we call, FOIL that out. Now this is all underneath the square root, so it's the square root of t plus 7 times the square root of t plus 7, so that is just t plus 7. Now we've solved quadratics, that's what we've been doing, so what we're going to do is get everything all to one side. I'll subtract t and subtract 7, so minus t minus 7 minus t minus 7. Let's see what I get. I get t squared plus 9t plus, I think that would be what, 18 equals 0. Now let's see if this factors nicely. T plus factors of 8, 1 and 18, 2 and 9, 3 and 6. 3 and 6 are going to be my winners here, 3 and 6, because they're going to make my 9. So I have that t equals negative 3 and t equals negative 6. Those are two answers to this bad boy, but like I said, you've got to check, even though we don't want to. So let's plug it into our original. So let's do the number 1, t equals minus 3. Minus 3 plus 5, that equals 2. Let's see what this is. Minus 3 plus 7, that equals square root of 4, which is 2. That one checks. Cool. Maybe they'll both work. T equals minus 6. Minus 6 plus 5, that's a negative 1. Let's see. Minus 6 plus 7, that equals square root of 1. Uh-oh. That is not true. You don't work. All right. Oh my goodness, look at this guy. He's got 2 square roots. Now I can't get the square roots all by themselves, both of them, because it just wouldn't, that's not even possible. So I have one of the square roots by himself, so that's good. That's where I'll have to start. And remember, I'm going to square both sides. Now my left side, I like that one. That's just x minus 3. But this right-hand side, oh my goodness, I've got the square root of x minus 3 times the square root of x minus 3, and this is messy. Let's look at it. This is going to be square root of x times square root of x squared, which is x, minus 3 square roots of x, minus 3 square roots of x, plus 9. Are you kidding me? Okay, I'm just going to combine these two things on the right side, see what I get. Minus 6 square roots of x plus 9. All right, I'm going to, let's try to get all the x's on one side, I guess. So let's not deal with the square root right now. Let's just minus x minus x. Oh, well, that's handy. Look how those x's just both drop. Whew, that's kind of nice. So then I have minus 3 equals negative 6 square root of x plus 9. I'm going to subtract 9 from both sides. minus 9, minus 9. And then we have negative 12 equals negative 6 square root of x. Okay, I'll divide both sides by negative 6. And then I have, whoops, that should be a 2 right there. So then I have, I'll go up here, square root of x equals 2. Square both sides, x is 4. Now that's my answer. But what do I have to do to these guys? I always have to check. So let's make sure it checks out. Square root of 4 minus 3. That's a 1. Okay, let's see what square root of 4 minus 3 is. That's 2 minus 3. Uh-oh. This is a negative 1. Well, look at that. No solution. Well, it sure did look like it was going to have a solution, didn't it? You see what I mean? These things can drive you crazy. All right, let's go for the next one. You just have to be really careful, and you always need to check your answers. All right, guys, here we go again. This is another messy one. Notice how I can't really get that, just a single square root, because I have 2 square roots in this, so I can't get both of them by themselves, so I just have to get one. And then I square both sides. All right. And then I just start simplifying. Left-hand side, I like this one. Got that. Equals. All right, now this is going to be 1 minus the square root of 2x times 1 minus the square root of 2x. And I got to multiply all that out. So let's keep that left like it is for right now. 1 minus the square root of 2x minus the square root of 2x plus square root of 4x squared. I'm just going to write that as 2x because I know that'll be 4x squared, so that'll be 2x. All right, so we've got x plus 1 equals 1 minus 2 of these 2 square roots of x plus 2x. All right, let's start moving stuff around because I'm simplified now. I'm going to subtract x from both sides, subtract x from both sides. You're gone, leaving me with 1 equals 1 minus 2 square root 2x plus x. Okay. Let's get, I'm going to want to start moving stuff to the other side, I think, actually. So anyway, I'll move the 1 first. Let's do that. Let's subtract 1 from both sides. They go away. That's pretty handy. So I have 0 equals negative 2 square root 2x plus x. All right. Need a little more room here. I'm going to move this little chunk of stuff over to the other side. I'm going to add it to both sides. So what I'm going to do is say plus 2 square roots of 2x plus 2 square root of 2x. Ooh, x. Then I'll get x equals 2 square root 2x. Now, I got the square root here, and I can square both sides at this point, and it'll be okay. Because I'll get x squared here. I'll get equals 4 times 2x. Okay. So I have x squared equals 8x. Yikes. All right. So then what I'm going to do is move this 8x over to the other side. I'm going to need more room. So I'm going to subtract 8x from both sides. I'll get x squared minus 8x equals 0. And this is quadratic. That's why I moved everything over to one side. Notice that I have a common factor. That's an x. So there's what we have. So I have that x is either equal to 0 or it's equal to 8. Now, Those might or might not be answers. I don't know. I have to check them, so we'll check. Number 1, x equals 0. Let's see what this equals. I've got square root of 0 plus 1. That's going to be equal to 1. Let's check the other side. 1 minus the square root of 2 times 0. That's 1 minus, that's a 1. Okay, this one checks out. That 0 works. Let's do number 2. Oh, what am I putting in? Forgot. 8. X equal 8. Square root of 8 plus 1. Well, that equals square root of 9, which is 3. Let's try the other guy. 1 minus the square root 2 times 8. That equals 1 minus the square root of 16. That equals 1 minus 4 equals negative 3. You do not check out. Let me go over there and do my x. Only have one solution for that one, and this one happens to be 0. Oh my goodness, these can be long and frustrating. If you need help, you need to be sure and let me know. Here we have the graph of y equals the square root of x. Now, if you want to do this, you would take your calculator, your TI 8384 calculator. You'll hit y equals, which is right there up underneath your graph, and then you'll key in square root x, and then you'll hit graph. You should get something that looks like this. So enter. Equation into y equals. Then hit graph. If you'd like to look at the table of values so that you can look at this table, you'll hit your second key. Usually it's either blue or yellow, because if you'll notice, your table key is written in one of those colors, and then you'll be able to scroll up and down through the table and get your XY points to plot. If you wanted to, you could generate your own table just by plugging them in. So like if you wanted, if x is 0, you'll plug in for y, you say square root of 0 equals 0. That's how they got this one. If x is 1, square root of 1 is 1. That's how they got that guy. If x is 4, square root of 4 is 2, and that's how they got that guy, and so forth. So if you'll look, there's nothing on this side over here because square root is undefined for negative numbers. So they all have this general shape. They might be skinnier or taller, or they might be flipped around, but this is their general shape. That's the shape of the square root of x. Now, isn't this one interesting? This is a graph of the cubed root of x. And note that we don't have any restrictions whenever we graph the cubed root of x. Therefore, we get to see that kind of shape flop over into this negative realm over here. You can graph this one on your calculator as well, or you can plug in values, plot points, and look at the pattern. But this is what you'll find. If you need help with your calculator, because your calculator is a tool that you really need to know how to use, be sure and send me some emails and I can send you some steps on how to get different things out of your calculator that might be helpful. All right, as always, if you need anything, don't hesitate to contact me. You'll see my cell phone number, you'll see my email address. You can stop by my office on the KRC campus, Ward 225. All right, y'all have a wonderful day. Bye now.